Hello, my name is Bruce Rose. I'm an applications engineer with CUI Incorporated. And first off, I want to thank you for making the time to listen to this presentation. Today, we will be discussing differences between internal and external power supplies in new product designs. Okay, I'll make a very obvious statement, and that is your product will probably require power to operate. There's very few products that don't really require power to operate. Perhaps a passive product we can think of might be one that has a resonant circuit and it affects the transmitter somehow, and the transmitter then uses that information of the interruption caused by the resonant circuit. There's fairly limited applications for that sort of product, but they exist. More common, perhaps, for very low power or very low energy would be referred to as energy harvesting. And the sorts of energy sources that we might use that we're harvesting is sound, light, heat, motion, radio frequency, those sorts of things. These are typically very low power applications. Very common application that we're aware of these days is Internet of Things, very ubiquitous, typically very low power. There is another form of energy harvesting that is common these days, though, that is actually high power, and that is the wireless power delivery, like might be used for charging an automobile battery or a laptop battery or a cell phone battery. In a case of that, it's another form of energy harvesting, but rather than using random energy that's already existing in the environment, what we're doing is we're specifically launching energy into the environment to be received by your product. Particularly with the high power, wireless power, your product may be required to deliver the power source and not only be the receptor of the power. So power could be required in either of those, even though it's energy harvesting. Another common form of power for products is batteries. And a battery either can be a single-use battery, in which case when it wears out, you throw it out, or it could be a rechargeable battery, in which case when it wears out, you recharge it. And in that case, external power will be required for charging the battery. Another category of power sources for products is AC wall power, and I think we're all very familiar with this. There can be two classes of power supplies there that are commonly called out. One would be internal supplies, and that is power supplies that are located internal to the chassis of the final product. And the second one would be external supplies. And these supplies, as the name implies, would be located external to the chassis of the product. And I'll go into this in a little more detail later, but there's always the option of taking an external supply and actually putting it internal to the chassis of the product. Okay, now we'll just look at the AC input side of power supplies, and we're going to limit ourselves to a reasonable range of power consumptions in this presentation, and that'll be from a few watts to maybe a few hundred watts. Things may be a little different when you go lower in power. Definitely things can start to change when you go higher than a couple of hundred watts, and that's not the intent of this presentation to be covering that. Two types of products that you might find in these power ranges of a few watts to a few hundred watts. One would be portable products. These generally are compact. They're often designed to be easily carried by a person and may contain batteries. Typically, some sort of external power supply is used in addition to the internal batteries, either to recharge the batteries or to run the product when the batteries are not present. Another category of product might be referred to as a stationary product. And these typically are heavier, and more often once they're put down in a location, they are not moved around. And that type of product more often might have an internal power supply. It just makes for a more clean presentation of the product. The output voltage and the maximum load current also may affect the choice of an internal versus an external power supply. And our recommendation is on the output voltage to, first off, on either class, internal or external supply, is to use a standard output voltage for ease of procurement. And by standard output voltage, what we're referring to is something like maybe 12 volts. It's more common than 9 volts, although 9 volts is fairly common. But if you go to something like 11.3 volts, that's definitely not a common voltage, and it'll be harder to procure power supplies with strange output voltages. Again, 12 volts, 24 volts, 15 volts, 5 volts, these are very common output voltages. By choosing a voltage like that, both again on an internal or an external supply, you will find more choices available from vendors. They will probably be more readily available in stock already. And if you need some other voltage for part of your supply or your product, you can use a DC-DC voltage regulator to create the custom voltages. The difference between selecting an internal and an external supply regarding the applied voltage is an internal supply generally will be able to provide a tighter voltage tolerance. And the reason for this is many factors lead into this, but shorter output cables from the power supply to the load means that there's less voltage drop along the cables with changes in load. And then on many internal supplies, there's the feature of remote voltage sensing. What this does is takes an extra pair of lines and runs it directly to the load. These are non-current carrying lines. They're just sensing lines. It enables the power supply to set the voltage at the load to the desired voltage. Again, an internal supply, for a number of reasons, will tend to provide a more accurate voltage delivery. An external supply, in contrast, will have some voltage error due to the typically longer DC output cable. The current times the impedance of the cable will create a voltage drop, and that voltage drop changes depending upon the load current being drawn. External supplies, low tolerance output voltage can be compensated for by putting either a low dropout linear or switching regulator in your product, or a more traditional, perhaps isolated switching converter inside the product to convert the low tolerance external supply voltage to a high or tight tolerance internal voltage. Something else that will that affects the choice of supplies is the power or load current rating, and that affects both the size and the cost of the supply, and it affects both the internal or an external supply in a similar manner. And that the supply needs to be selected for peak load power or current delivery capability. And some examples of loads that have unusually high peak currents may be motors during their startup, or capacitors when they're being charged. And quite often, you may have to select a supply with a very large power delivery capability just to handle the very initial conditions. Changing the maximum power on the supply will affect the thermal design of the supply and many of the electrical protection circuits inside. And so that may affect the size and the selection of the supply. But again, it should apply to both internal and external supplies. Okay, with regards to your product may have a physical configuration that you desire, and that is what we will refer to as integrated or modular. And what I would call an integrated supply, and that is where basically all that comes out of it is a power cord for the power in, and then whatever cables may be required for the product itself, and then user interfaces. And this will have a cleaner design. And in that case, by definition, the power supply will be located internal to the product. Perhaps it may be viewed as more versatile if you do what would be called a modular design, and that is having the power supply outside of the product using external power supply. In this case, the product can be smaller and lighter without containing the power supply. A great example is your cell phone or your laptop computer. No dangerous voltages need to be addressed by the customer. All the dangerous voltages are contained within the external power supply. And as was mentioned once before, the external supply could actually be physically located inside of the product but still make use of an external supply so that the development team does not need to deal with the dangerous voltages. There are different AC input standards that need to be accommodated when designing or selecting a power supply. In particular, if you look at addressing international markets, then many of them have different AC plugs. And so if you have one product that will be addressing international markets, you may need the ability to have different AC plugs for the same product. If it's a internal supply, then probably what you're going to have is an AC power cord that is plugged into an AC receptacle on your product. The power cord may be hardwired to your product, but it may be plugged into a receptacle. But to change the AC plugs for different international markets, you merely change the power cord. With an external supply, you will find a similar situation, and here we'll start to differentiate between a desktop supply and a wall mount supply or a wall plug supply. A desktop supply, as the name implies, typically is located on the desktop, maybe on the floor. It has an AC power cord coming in and a DC power cord going out. And to change the AC plug on a desktop supply, again, you change out the AC power cord, and then you have a new cord for the different international market. There may be some desktop supplies with hardwired AC power cords, but it's very common to find them going into an AC receptacle. Wall plug supplies are, if you will, similar but different, in that on a wall plug supply there is no AC power cord, but instead the blades are attached directly to the body or the case of the power supply. And so you have two options for international power on a wall plug power supply. One is to just use different power supplies for each country with the different AC plugs present. The other option that you would have is to use what's called a multi-blade power supply. And this is a case where basically you can think of it as taking the power cord and shrinking it down so there is no cord. There's just the AC input blades and the AC output connector that goes into the receptacle in the power supply. In the case of a wall plug supply, again, they take the mechanical and electrical connection and it's configured together, and it allows you to swap different blades that plug into the different wall sockets for AC power. One other choice you have to worry about with AC power is whether you want a 3 or a 2 conductor input cord. And again, if you recall earlier, we're talking down at a few hundred watts. So this is single phase AC design, and we won't discuss multi-phase AC design. But with single phase AC design, power is conducted over 2 conductors. If the third conductor is present, it's therefore ground, which is a safety feature. Not all products require that ground, and so you have to decide if your product will or will not require the addition of that ground conductor. With or without the ground conductor will throw the power supply and your product into what is referred to as a class Roman numeral 1 or class Roman numeral 2 configuration, and that is whether or not ground is present in the power supply. And also the choice of bringing that AC safety ground in will help determine whether or not your output of your power supply, the DC output, is floating relative to ground or it's ground referenced. Obviously, you have to bring ground in if the output is going to be ground referenced. Now let's talk, we talked about the AC input going to the power supply. Now we'll talk about connecting the DC output to the load. On internal power supplies, typically the power supply vendor will provide some form of connector, screw terminals or plug or something on the output of the power supply. Then it's up to the system designer to specify the cable that goes between the power supply and their load. Talking to some of the power supply vendors, you may be able to get them to supply the cable that you have specified. That's with an internal supply. With an external supply, the DC output cable is already present on the supply. However, there may be the opportunity to customize the DC output cable. The length may be able to be shortened or lengthened. If it's shortened, that's normally not a problem. Lengthening it, you just have to be careful that there may be safety regulatory concerns or efficiency concerns if the cable gets longer. Similarly, the thickness of the cable. It oftentimes is a desire to have it as small as possible to make it less intrusive. However, when that happens, the efficiency of the supply drops because the efficiency includes the losses in the output cable, and so there may be some limits due to efficiency regulations of how small the output cable can be made. We'll talk about this more later, but you also may have a choice of color, texture, that sort of thing on the output cable. The connector itself that sits, on the end of the output cable also can be customized. And some common things that come to mind would be bare wires if you have the desire to hook that in something in your product, or maybe a barrel connector, which as the name implies is two concentric barrels, if you will, one carrying the positive output voltage and one the negative voltage. USB is a very common style of connectors these days. The USB type A has been common. There's been variants of that, and most recently the USB type C. It's a whole other discussion going into what the USB type C means, but suffice it to say, one of the things with the USB connectors is tradition says that there are specific voltages that one uses through a USB connector. So if you're using a non-standard USB voltage, you may choose not to use a USB connector. Another common connector for higher power applications is referred to as a DIN connector. And this is actually of German origin, but it's used worldwide these days. And typically in power, you may see 4 contacts in the DIN connector, and they tend to be slightly higher current. They're physically bigger than a barrel connector or a USB connector. In addition to the electrical connection, you may choose to have latching on your DC plug so that the DC plug cannot inadvertently be disconnected from the jack into which it's plugged. And the latching may be, there's what's referred to as bayonet, which is like 1/8 or 1/4 of a turn once it's inserted, or it can be a threaded one that takes numerous turns in order to secure the plug into the jack. Another type of latching is magnetic latching, and we've seen that on products recently. And then similarly, one might wish to have waterproof jacks. So all these sorts of variants are possible when selecting the DC output connector on an external supply. And when you're talking with your power supply vendor, you may well be able to get not only the plug put on, but an overmold put on such that the plug does not look like it was an aftermarket product, but it was produced during production. The next topic we'll now be talking about is EMI and EMC. EMI, electromagnetic interference, and EMC, electromagnetic compatibility. And these issues will be common to both internal and external supplies. And what they relate to is how the product affects other products due to electrical noise that it produces, and how it is affected by noise produced by other products. The noise we're talking about, the electrical noise, can be radio waves, it could be static electricity, unexpected input voltage surges, or other artifacts such as those. For now, I will only address radio waves, and they are either referred to as conducted or radiated emissions. These emissions actually are most often caused by the load, but addressed by the power supply because the testing to detect this conducted and radiation emissions is typically not done until the system is nearly complete. And at that point, the power supply is present and the radiated and conducted emissions are oftentimes detected near the power supply. So therefore, it is viewed as potentially the source of it and the place where the solution should be found, but it is not necessarily actually the source of the problem. So on conducted emissions, as the name implies, they're conducted through the input power cord, and by regulatory definitions, they are at 30 megahertz and below. And they'll affect internal and external supplies in a very similar manner. Radiated emissions, as the name implies, they're radiated rather than conducted, and by definition, regulatory definition, they are above 30 megahertz. Internal supplies do not tend to have the radiated emission issues only because, or primarily because, the DC output cord between the power supply and the load tends to be short and therefore makes it a very inefficient antenna. And if the antenna is very inefficient, there's not much radiated energy coming from it. Also, there's the chance that the product chassis may well shield some of the radiated energy from being emitted. On an external supply, it is quite often the case that radiated emissions turn out to be an issue. It is an issue, but it is well known and it is easy to deal with, and that is that what are referred to as lossy ferrite beads are put on the DC output cable, and this absorbs the energy coming from the load and does not allow the DC output cable to act as a very efficient antenna. Regarding external mechanical modifications one might choose to make to a power supply. Many power supplies will have regulatory certificates when purchased from the power supply vendor. The changes for performance reasons may affect the mechanical configuration and may affect regulatory approvals. Some of the changes you might choose to make for performance reasons, for example, is output voltage. Probably that will not affect the mechanical configuration. If it does, it's probably actually a redesign of a power supply rather than a modification. But depending upon how the power supply design team has defined the product, when attaining the original regulatory approval, changing the output voltage even slightly may require new regulatory approvals. And this would be the case in either an internal or an external supply. The operating temperature also is a concern in a power supply, and to change the operating temperature may require external mechanical modifications. The challenge there is if you're trying to operate at a higher temperature, you need improved power dissipation. If you're trying to operate at a lower temperature, quite often those are electrical component limited, and so you may have to change out components. If changing these components changes the size of things, that may affect the mechanical modifications. We don't tend to see many modifications done to internal supplies. We see external supplies modify fairly regularly. The input voltage is normally not an issue on power supplies, and that most power supplies these days are switching topology power supplies. The input voltage is already defined for a range of a nominal 110 to 240 volts, and so that hits the majority of the applications. The user may choose to request additional features such as overvoltage protection, overcurrent protection, undervoltage lockout, over temperature protection, or something such as that. Again, I would caution you, typically if you're going to be adding something like that, it turns into a redesign of the power supply rather than a modification of the power supply. And so probably it's a major endeavor. As we've talked before, the AC input plug can readily be changed. Typically that is done with the power cord itself, and the DC output cable can be changed. Something to note is on an external supply, the DC output cable obviously passes through the wall of the case. When you change the DC output cable, if it gets too big, it no longer passes through the existing hole in the case. Changing that may affect regulatory approval. Normally, regulatory approval is affected by safety issues. The case is deemed a safety item, as is the high voltage sections of the power supply. You can also change the DC output plug as part of an external mechanical modification. That normally does not affect regulatory issues. Let's look at now something that's perhaps a little different, and that is the marketing aspect, which is the brandability of your adapter, or the branding of your adapters. And again, this will apply more to external supplies because the end user sees them than it will to internal supplies. But the advantage, or why a customer may choose to do this, is it helps to promote name recognition. It promotes product recognition, and it can be of branding benefits. These do not normally affect regulatory approvals, so normally they're very simple to do. Some of the customizations that are commonly done is the adhesive label on the product may be changed and customized. It's possible to silk screen, laser etch, emboss or deboss logos onto a package. The color and the texture of the package could be altered, or the input or output powered cord length, size, color, and texture could be changed. Again, these changes tend to affect an external supply much more than an internal supply. Most internal supplies are not visible to the end user, so there's really not a concern of what it looks like or how it's labeled. With regards to these customizations, some of them may be available for little or no cost, but the thing that they may do is they may affect the lead time or the minimum order quantity of your product and power supply that you're designing, because again, it is custom built for you. So that's something to talk with your salesperson and decide if you perceive that as a benefit. Many customers do perceive that as a benefit on external supplies. There's also the packaging that the adapter goes into. We just completed talking about the adapter itself and the appearance of the adapter. You also have the ability to change the package that the adapter arrives in. And keep in mind that your customer's first impression of your product is when they open the package. And so having an appropriate package helps on the first impression the customer has when receiving your product. Again, it'll help provide name recognition, product recognition, and branding benefits. Some of the customizations available is the gift box style and label. The gift box is what we call the actual box that the power supply comes in. There are additional packaging alternatives that one could choose: plastic packaging, a bag, no packaging, things like that. Again, you can talk with your salesperson and find out what is available and what would be beneficial to you. Again, many of these customizations are available for little or no cost, but may affect the lead time and minimum order quantity with regards to the supply. One of the things you ought to keep in mind when choosing a supply, and again, this applies to either internal or external supplies, is the design support that you will receive. And such things as three-dimensional models, if it's internal or external, that's important. The printed circuit board footprint on which the supply will reside, that's more important on internal supplies. Technical papers that help to address some of the features, benefits, and characteristics of the power supplies. CUI offers a power blog that we put out periodically addressing different concepts in a short form regarding power supplies. We have some videos that again explain some of the technical characteristics of our supplies. And we have a frequently asked questions page if you wish to look for information there. This concludes my presentation. I want to thank you for making the time to listen to this. And it is our hope that all of you, your families, and your friends, please stay safe and healthy.